Local AI infrastructure and sovereignty. The conversation around self-hosted AI has matured beyond simple run-it-yourself enthusiasm into systematic frameworks for understanding exactly what you're trading off at each tier of independence. A new guide mapping LLM options from ChatGPT web apps to fully self-hosted infrastructure attempts to codify these decisions, covering cost, data control, and the often underestimated friction of migrating between providers. The term LLM sovereignty sounds grandiose, but it captures something real. Organizations increasingly recognize that their AI stack is strategic infrastructure, not just another SaaS subscription. The hardware enabling this sovereignty continues to evolve in interesting directions. One enthusiast managed to squeeze an RTX Pro 4000 Blackwell SFF into a Minisforum MSS1 Max, AMD Strix Halo, running it through a PCIe 4.0x4 slot extended to X16, achieving roughly 170 to 200 tokens per second on prompt processing and 25 to 30 tokens per second generation with Minimax M2.1 at Q4 KXL quantization. The benchmarks reveal the persistent gap between CUDA and ROCm performance. The same model running on ROCm 7.1 achieved only about a third of the CUDA prompt processing speed. For those building serious local infrastructure, these details matter enormously. On the software side, Clariverse has returned with improvements after incorporating community feedback, positioning itself as an all-in-one local AI workspace with 50-plus integrations spanning Gmail, Sheets, Discord, and Slack. The pitch is familiar: build agents that actually do things rather than just answering questions, but the emphasis on chat-first workflow building and automatic API endpoint generation suggests the local-first movement is converging on what enterprise tools have been doing, just without the data leaving your premises. The claim that conversations never touch the server, even when self-hosted, deserves scrutiny, but it reflects genuine demand for privacy guarantees that cloud providers structurally cannot offer. AI agent development and multi-agent systems. The single-model trust problem has spawned an interesting solution. Force multiple AIs to argue before giving you an answer. Kia Research is a self-hosted platform that routes ChatGPT responses through verification against other models, Gemini, Claude, Mistral, Grok, or local Ollama instances, in structured discussions designed to surface disagreements and reduce hallucinations. The approach is provider-agnostic, letting users mix API-based and local models. Community reaction ranged from enthusiasm, "This is exactly what the AI world needs," to practical concerns about computational overhead and whether the models genuinely critique each other or just engage in what one commenter colorfully called a giant circle jerk of AI handshaking. The question of whether multi-model consensus actually improves accuracy, rather than just averaging out different flavors of wrong, deserves empirical testing. The gap between prototype and production agent remains a core challenge. MuleRun's Agent Builder attempts to bridge this by letting users describe agents in prompts and compose them from skills that form consistent workflows, all running in the cloud. The pitch targets people who already code with Claude but want agents that persist and can be reused. Meanwhile, a more fundamental problem has surfaced. Agent references break every time you migrate servers. One developer's solution is a URI scheme where identifiers don't contain network addresses. agent/cme.com/workflow/agent01h455vb, with the path representing capabilities rather than location and a distributed hash table handling resolution. There's an ABNF grammar, a Rust implementation, and an RxIV paper, 2601-14567, for those who want the formal spec, with efforts underway to get this into the A2A protocol. Browser automation for agents is getting more sophisticated. Vercel Labs at Cloudflow browser package provides 59 MCP browser tools with security-first design, including URL validation, phishing detection, and PII scanning. The trajectory learning feature records browser interactions for what they call reasoning bank SONA learning, storing successful patterns for reuse. The claimed 93% context reduction through element refs at E1, at E2, instead of full CSS selectors addresses a real problem. Feeding entire DOMs to language models is wasteful. Whether this approach generalizes beyond relatively static web interfaces remains to be seen. AI development tools and workflow enhancement. The statefulness problem in AI tooling keeps generating creative solutions. One developer is building what they call a cognitive OS, a browser-based system wrapping LLMs in a semantic relational graph with a multi-stage cognition pipeline, subconscious-conscious synthesis, plus its own memory system and internal workspace file system. The system routes different stages to different providers: Gemini, Fireworks, LM Studio, Perplexity, or Grok, and includes features like an explicit running context buffer with focal points and constraints, Fibonacci-style resurfacing for important information, and an IndexedDB-backed file store with staging overlay for diff commit discard workflows. Whether this complexity pays off depends on use case, but the underlying insight is sound. Treating LLMs as stateless chat toys wastes enormous potential. The desire for conversation branching, Git-style version control for AI chats keeps surfacing. Users spending 4 to 5 hours daily in Claude or ChatGPT describe the frustration of realizing 15 messages deep that they should have asked something differently 8 messages ago. Claude Code users can somewhat address this with checkpointing and the /fork command, but web interface users are stuck with workarounds like manually carrying multiple conversation branches with explicit labels. The underlying problem is that conversational interfaces collapse what should be tree-structured exploration into linear transcripts. On the defensive side, Jeffrey Emanuel's Destructive Command Guard (DCG) tool addresses the very real problem of coding agents deleting your data. Written in Rust for speed, it runs on every tool call via Claude Code's pre-tool hooks. DCG checks whether a command could delete data, drop tables, or otherwise cause irreversible damage. The engineering challenge is avoiding false positives while catching creative circumvention. Models will use ad hoc Python or Bash scripts to work around simple block lists, so DCG employs AskGrep-powered parsing for Herodox scripts. Speaking of AskGrep, the underlying tool is worth knowing, a CLI for code structural search, lint, and rewriting that matches AST nodes rather than text. Webcode extends this ecosystem further, offering a browser-based platform for remotely running CLI assistants like Claude Code and Codex. AI model architecture and innovation. StepFun has released Step 3 VL10B, a multimodal foundation model that punches well above its weight class. Despite its compact 10B parameter footprint, it consistently outperforms models under 10B and rivals or surpasses significantly larger open weights models 10 to 20x its size, including GLM 4.6, 106B A12B, and Qwen 3 VL Thinking 235B A22B. The technical approach combines unified pre-training on a 1.2T token multimodal corpus with a rigorous post-training pipeline including over 1,400 iterations of reinforcement learning with both verifiable rewards and human feedback. What makes Step 3 VL10B particularly interesting is its parallel coordinated reasoning, PACOR mode, which allocates test time compute to aggregate evidence from parallel visual exploration rather than relying solely on sequential chain of thought. The benchmark results are striking. On AM 2025, PACOR achieves 94.43% versus 87.66% for sequential reasoning. On AT 2025, the gap widens to 92.14% versus 78.18%. This suggests that for certain problem types, how you spend inference compute matters as much as model scale. The model is available in both base and chat variants, with the base model potentially useful for researchers exploring the perception encoder and Qwen 3.8b decoder synergy. On the architectural innovation front, RuVector proposes a fundamentally different approach to AI systems, not a text predictor, but a structural world model, representing reality as vectors, graphs, constraints, and signals. The objective shifts from guessing the next token to maintaining internal coherence as the world changes. The key mechanism is dynamic minimum cut, which continuously measures structural tension inside the graph. Disagreement becomes signal rather than failure. Whether this approach delivers on its ambitious framing remains to be demonstrated, but the shift from "is this answer correct?" to "is this world still intact?" represents an interesting philosophical reorientation. Memory systems for agents continue evolving beyond simple vector stores. AMEM introduces a memory layer building semantic graphs rather than treating memory as isolated vectors, extracting keywords and context from each addition, then linking and strengthening relationships automatically. The skeptical view: this still depends on heavy LLM calls for every memory addition and linking step, raising obvious latency and cost questions. The optimistic view: automated linking and graph evolution could meaningfully reduce redundant token usage. The engineering test is whether benefits outweigh the complexity and cost introduced. AI evaluation and quality assurance. Anthropic's Tristan Hume has published a detailed account of designing take-home tests for performance engineers that remain effective as AI capabilities improve, a problem that will become increasingly relevant across technical hiring. The core challenge: an evaluation that distinguishes well between human skill levels today may be trivially solved by AI models tomorrow. Claude Opus 4 outperformed most human applicants on their original test, and Claude Opus 4.5 matched even top candidates under identical time constraints. The solution involved building a Python simulator for a fake accelerator with characteristics resembling TPUs, where candidates optimize code using a hot reloading trace. The key design principles: problems should give candidates a taste of actual job requirements, avoid hinging on single insights, ensure wide scoring distribution, prioritize good fundamentals over narrow expertise, and include fast development loops with room for creativity. Anthropic explicitly allows AI tools on this take-home as candidates would use on the job, but longer horizon problems are harder for AI to solve completely, so candidates still need to demonstrate their own skills. The iterative refinement across 3 versions of the evaluation reveals what makes technical assessments robust: problems requiring sustained reasoning over multiple steps, integration of multiple concepts, and tasks where even partial AI assistance still leaves meaningful human contribution. This is less about tricking AI and more about identifying the actual skills that matter when AI is a ubiquitous tool. The implicit lesson for the broader industry: evaluation design is becoming a distinct skill, and organizations that ignore AI capability growth in their hiring processes will increasingly select for candidates who are good at using AI rather than candidates who possess the underlying skills being nominally tested. The conversation about AI's impact on knowledge work more broadly is crystallizing around frameworks like Sangeet Chaudhary's analysis of how systems transform through constraints. The shift from AI automates tasks to AI restructures systems captures something important. When capabilities become commoditized, value migrates to coordination and risk management, rather than disappearing entirely. Infrastructure security and reliability. A significant Kubernetes security vulnerability has been reported and closed as working as intended, a classification that should concern anyone running clusters with distributed access. Users with only nodes proxy get permissions can execute commands in any pod across a cluster, including privileged system pods that could lead to full cluster compromise. The root cause: the kubelet authorizes requests based on the initial WebSocket handshake's HTTP GET request, only verifying GET permissions are present without a secondary check for create permissions for the actual write operation. Particularly concerning, commands executed through direct kubelet API connections are not logged by Kubernetes audit policy. The kubelet API endpoint, port 1025, does not traverse the API server, so while authorization checks generate logs, the actual actions do not. This means an attacker with nodes proxy get permissions and network access to kubelet ports could execute arbitrary commands across the cluster with minimal forensic trail. The vulnerability highlights how RBAC design decisions made for one context, API server proxying, can have unexpected implications in another context, direct kubelet access. On the infrastructure reliability front, Cloudflare disclosed a route leak incident where an automated routing policy configuration error caused unintentional BGP prefix leaks from their Miami data center. The incident joins a pattern of Q4 2025 disruptions, including cable cuts, power outages, and extreme weather. Separately, a DNS resolution issue stemming from altered CNAME record ordering demonstrates how subtle changes in infrastructure behavior can break clients that depend on undocumented assumptions. The broader lesson: As AI systems increasingly depend on network infrastructure, understanding these failure modes becomes essential for reliability engineering. AI operating models and strategic implementation. The shift from AI use cases to AI operating models signals that organizations are beginning to treat AI as ongoing obligation rather than tool evaluation. The diagnosis converging across consultancies and board decks. AI failure is rarely about the model being not smart enough, but about organizations not being structured to absorb what the model changes. The constraint is accountability, not intelligence. This framing is largely correct. Pilots stall because organizations don't change how they run. Ownership fragments across IT, data, risk, and operations. Governance arrives late after momentum has formed and expectations have moved. But there's a hidden assumption. Most operating model work begins from, we're going to do this, so let's do it responsibly. By the time you're drafting decision rights, controls, RACI charts, and forums, you're already behaving as if scaling is inevitable. You're socializing the future internally, shifting budgets, redefining roles, lining up external partners. Stopping now has social cost, so organizations reach for structure as a way to keep moving. The insight that an operating model is the wiring under the board, what organizations actually rely on when things get messy, clarifies why this conversation has energy. It's the system noticing that a promise is about to be made. When work stays human and slow, that wiring can be partly implicit. People patch over gaps with judgment, relationships, and escalation. AI accelerates decisions beyond the speed at which implicit coordination works. Operating model work is not just good practice, it's the organization catching up to the velocity it has already committed to. Specialized AI applications. Project Icarus is a synthetic dataset generator designed for training AI models to detect combat drones, Shahed 136, Orlan, Geranium 2, and similar systems. The mythology reference is deliberate. Hostile drones will share Icarus's fate, identified and taken down by AI-powered detection systems. The practical motivation is straightforward. Collecting real-world imagery of combat drones presents significant challenges, including availability. These aren't available for photography sessions. Safety. Capturing images in operational environments puts personnel at risk. Legal restrictions. Military equipment photography is often classified. And cost. Manual annotation is time-consuming and error-prone. Synthetic data generation addresses these constraints by producing unlimited, perfectly labeled training data with automatic bounding box annotations in industry-standard formats. The generator can create any lighting condition, weather pattern, or viewing angle on demand, avoiding the domain gap problem through camera matching capabilities. Research from MIT demonstrates that synthetic data can offer real performance improvements in machine learning, and the synthetic data market is projected to grow from $2 billion in 2025 to over $10 billion by 2033. The recommended approach is using Icarus to generate bulk training data, then fine-tuning with real-world samples for optimal results. This reflects the broader pattern in AI development. Synthetic data handles the long tail of scenarios that are expensive or impossible to capture in reality, while real data grounds the model in actual sensor characteristics and operational conditions. For defense applications specifically, the ability to rapidly generate training data for emerging threat types, new drone models, modified configurations, novel operating patterns, represents a significant capability advantage.